At 3:38 in the morning on July the 12th, 2026, hundreds of people across Southern California shot up in bed at the exact same second. Dishes rattled in cupboards, dogs started barking in the dark, phones buzzed with an emergency alert seconds before the ground even started moving. The earthquake itself was only a 4.2. That is not big enough to hurt anyone. It is not even big enough to crack a window. On paper, it should have been forgotten by lunchtime. But here's the part that made scientists sit up and pay attention. The spot where this quake happened has not moved like this in at least 26 years. And that patch of ground sits inside one of the most closely watched, most talked about, most feared regions in the entire state of California. Researchers have spent decades waiting to see what happens when this exact area finally wakes back up. Now it just did. And when scientists went digging into exactly what caused it, they found something that was not quite what anyone expected. Stick around, because by the end of this video, you're going to understand why one small shake at 3:38 in the morning has some of the top earthquake experts in the country checking their data every single day since it happened. The 3:38 a.m. wake-up call. Let's start with exactly what happened, because the small details here matter a lot more than you might think. The earthquake struck just outside a small mountain town called Fraser Park. If you have never heard of it before, that is completely normal. It is a quiet little community tucked up in the mountains, sitting right along Interstate 5, about 70 miles north of Los Angeles. It is the kind of place with a gas station, a small grocery store, and a lot of pine trees. Not exactly the setting you would expect for a story about dangerous fault lines. Most people who drive through it are simply passing between Los Angeles and the Central Valley on a road trip. They barely glance at the exit sign as they go by. At 3:38 in the morning, the ground about 8 miles below that town let go. The quake came in around magnitude 4.2, though in the hours right after, different instruments gave slightly different numbers. Some of the earliest readings said 4.1. The automated early warning system that tracks these events kept updating its number as more information came in, eventually landing closer to 4.4. That kind of back and forth might sound confusing, but it is completely normal right after an earthquake. Scientists are constantly refining their numbers as more sensors report in from farther away. It does not mean anything went wrong with the science, it just means the full picture takes a little time to come together. What is honestly the wildest part is how far this small quake traveled. People felt it shaking their beds in Bakersfield, they felt it in Santa Clarita, they felt it out in Palmdale, and even in parts of Los Angeles and Orange counties. Some reports even came in from as far away as San Diego, nearly 300 miles from where the ground actually moved. Almost 800 people filed reports with the United States Geological Survey just to say they felt their house shake that morning. Think about that for a second. A quake too small to cause any damage still managed to wake up people spread across a huge stretch of Southern California. The early warning system did exactly what it was designed to do. It sent out alerts seconds before the shaking reached people in nearby cities, giving them just enough time to brace themselves or step away from anything that could fall. That might not sound like much time, but a few seconds of warning is actually huge. It is enough time to duck under a table, enough time for elevators to automatically stop at the nearest floor and open their doors, and enough time for trains to start slowing down before the shaking even arrives. None of that happened at a large scale this time because the quake was too small to trigger those bigger safety systems, but the alert itself still reached hundreds of thousands of phones across the region in the middle of the night. A second, much smaller, quake hit the same general area a few hours later, almost like a small aftershock checking in to say the first one was not a fluke. There were no injuries and no real damage from either event, just a lot of very tired, very wide-awake Californians scrolling through the news at 4:00 in the morning trying to figure out what just happened. Now here is where you might expect me to tell you this earthquake was nothing to worry about, and taken completely on its own. That would actually be true. California gets thousands of earthquakes every single year. The vast majority are so small that nobody except a sensitive instrument buried underground would ever notice them. Only around 15 to 20 earthquakes reach a magnitude of 4 or higher in a typical year across the entire state. Out of every state in the country, only Alaska experiences more earthquakes each year than California does. A magnitude 4.2 barely even makes the local news on most days. So why is this particular one different? It comes down almost entirely to exactly where it happened. And that is a story that got a lot messier than most people realized in the first 24 hours after the shaking stopped. If you are new here, I cover breaking earthquake stories just like this one all the time, and I want to give you a real reason to actually stick around for it. Most channels grab the headline number, throw up a scary title, and move on to the next video. I like to wait for the real science to catch up first, because in earthquake reporting, the first explanation floating around online is almost never the full story. This exact earthquake turned out to be a perfect example of that. Hit subscribe so you actually see the follow-up the moment the real answer comes in, instead of just seeing the panic that shows up before it. To understand why this small quake had scientists on edge, we need to talk about exactly where it landed, because that part of the story changed fast, and it changed in a way almost nobody online expected. The fault nobody was watching. Within just a few hours of the quake, a theory spread everywhere online, jumping from account to account faster than the actual science could keep up. People said this earthquake hit the exact meeting point between two of the most dangerous fault lines in all of California, the San Andreas Fault and the Garlock Fault. It is an easy story to tell because it sounds genuinely terrifying, and to be fair, the epicenter really was close enough to that meeting point that the idea made sense at first glance. Here's the problem. When actual seismologists sat down and studied the real data, they found something different from what everyone assumed. The Southern California Seismic Network, the team of scientists who study this region for a living, said the quake did not occur on the San Andreas Fault. It did not occur on the Garlock Fault either. Instead, all the evidence pointed toward a much smaller, far less famous fault called the Plato Fault. Most people have never even heard of the Plato Fault, and that is exactly why this detail matters so much. It sits tucked in between the two giants running through the hills just west of the interstate near Fraser Park. It does not get the headlines that the San Andreas gets. It has never had a disaster movie named after it. But it lives inside one of the most crowded, most tangled up patches of broken earth anywhere in the entire state. Here's a way to picture it that actually makes sense. Think about a car windshield that gets hit by a small rock. Around that one main crack, you usually see a dozen smaller cracks spreading out in every direction, all connected to the same impact. That is basically what the ground looks like underneath Fraser Park. The San Andreas and the Garlock are like the two big, obvious cracks running through the glass. But woven all around them are smaller faults like the Plato, all caught up in the same stress from the same underlying pressure. So while the story about the quake hitting the big, scary junction turned out to be wrong, the real explanation is honestly just as interesting once you understand it. This lesser-known fault sits inside a neighborhood that is being squeezed from two completely different directions at once. On one side, the San Andreas Fault is grinding one way. On the other side, the Garlock Fault is grinding the exact opposite way. The chunk of land caught in between takes pressure from both sides at the same time. Almost like a rope being pulled by two different teams in a tug of war, neither one letting go. Something inside that tangled mess of rock was always eventually going to move. On July 12th, it finally did. Geologists who study this area often describe it as one of the most structurally complicated corners of the entire state. It is not one clean fault line running in a simple direction. It is a whole patchwork of smaller cracks and folds, all shaped by decades of two much larger forces pushing against each other. The Plato Fault is just one thread in that patchwork, but it is far from the only one. There are other small, quietly named faults scattered through those same hills, and most of them barely ever make the news because they almost never produce anything strong enough to notice. That is exactly why the July 12th quake caught so much attention. It was a rare reminder that this whole stretch of ground is alive and constantly adjusting, even when the big famous fault lines nearby stay completely still. This actually teaches us something more useful than the original rumor ever could have. It shows just how packed with built-up stress this entire region really is. You do not even need the two most famous fault lines in the state to slip for the ground here to shake. Smaller, quieter faults sitting right next to them can pop off entirely on their own simply because they happen to be caught in the crossfire between two much bigger systems, constantly pushing against each other. But that raises an even bigger question. If a small side fault like the Plato can wake up after staying completely silent for more than 2 decades, what does that say about the two much larger faults sitting right beside it? To answer that question, we need to look closer at the fault that keeps seismologists the most nervous out of the entire group, the giant that has been sleeping for 1,000 years. Out of the two major faults sitting near Fraser Park, the Garlock Fault is the one that genuinely keeps seismologists up at night. Here is why. The Garlock Fault stretches almost 160 miles across the desert, cutting east to west right along the northern edge of the Mojave Desert. It meets up with the San Andreas Fault out near the mountains above Los Angeles, forming that famous junction everyone online was talking about right after the quake. Scientists have spent years digging into the layers of dirt and rock along this fault, searching for physical evidence of earthquakes that happened long before anyone was around to write them down. What they found is honestly hard to fully wrap your head around. The evidence shows the Garlock Fault has produced genuinely massive earthquakes in the distant past, big enough to shift solid ground several feet in a single sudden event. Based on how these old rock layers stacked up over time, researchers believe the fault is capable of an earthquake somewhere around magnitude 7.5. To put that number in perspective, that would be roughly 30 times stronger than the small quake that woke everyone up on July 12th. But here's the part that should genuinely give you chills. There is no record, not a single one of the Garlock Fault producing anything close to that size during the entire time humans have been writing things down and studying this region with real scientific instruments. Researchers estimate the fault has gone somewhere between 500 and 1,000 years without a major release of energy. To put that in perspective, the last time this fault truly let loose People in Europe were still riding around on horseback in full suits of armor. California had not even been mapped out by explorers yet. That is how long this pressure has been quietly building up underground with nowhere at all to go. Faults simply do not forget about pressure like that over time. The rock on either side keeps grinding against itself year after year, century after century, locking together tightly in certain spots, and slowly building tension like a rubber band being stretched a tiny bit more every single day. Eventually, something inside that system has to give way. This is not a brand new worry for scientists either. Back in 2019, two massive earthquakes struck near a desert town called Ridgecrest, not too far from the Garlock Fault at all. First came a magnitude 6.4 quake, and then a magnitude 7.1 quake struck just a single day later. The strongest earthquake to hit California in more than 2 decades at that point. Scientists who studied the aftermath of that sequence found real, measurable evidence that stress along parts of the Garlock Fault increased noticeably because of it. Ground movement was actually recorded along certain sections of the fault in the months that followed something that had never been documented there before in modern history. In other words, the Garlock Fault was already carrying more pressure heading into this year than it had in long time. Now bring the July 12th earthquake into the picture, striking inside that same tangled web of smaller fault lines sitting right next to the Garlock's western end. None of this proves a massive earthquake is coming next week or even sometime next year. Scientists genuinely cannot predict earthquakes with that kind of precision, and anyone online telling you otherwise is not being fully honest with you. But it does mean this region is holding on to more built-up tension than it has in generations. And tension like that always has to go somewhere eventually. There's also a bigger historical pattern worth understanding here because the Garlock Fault does not sit alone in this story, just a short distance away. The southern stretch of the San Andreas Fault has its own long, quiet history that scientists have been tracking for over 2 centuries. Back in 1857, a massive earthquake known as the Fort Tejon earthquake tore through roughly the same general area, registering somewhere around magnitude 7.9. Before that, in 1812, a pair of powerful earthquakes struck the same broader region within days of each other. Since that stretch of the San Andreas last ruptured in a major way, more than 150 years have passed without a repeat. Meanwhile, most of the big headline-making earthquakes in recent decades, including the 2019 Ridgecrest sequence, have actually happened farther east, out in the desert. Some researchers believe seismic activity in this part of California tends to slowly drift back and forth between the eastern and western sections of the fault system over long stretches of time, sometimes taking 50 to 100 years to fully shift from one side to the other. If that pattern holds true, the recent cluster of earthquakes out east could represent the tail end of one phase, with pressure now slowly shifting back toward the western side, right where the Garlock and San Andreas fault systems come together. If the Garlock Fault by itself was not concerning enough, brand new research released just weeks before this earthquake found something even bigger happening along the fault system sitting right next door. And that discovery might honestly be the most important piece of this entire story. The stress levels scientists have never seen before, a few weeks before the Fraser Park earthquake even happened. A team of researchers quietly published a study that has become one of the most important pieces of earthquake science of the entire year. The team built a detailed model tracking roughly 1,000 years of earthquake history along the southern San Andreas Fault and a nearby system called the San Jacinto Fault. Their goal was simple to explain, even if the science behind it was incredibly complex. They wanted to figure out exactly how much stress has built up along these fault systems compared to any other point across the past 1,000 years. The answer they came back with was startling. According to the model, stress levels along these fault systems right now sit at or above anything recorded across the past 10 centuries. Not just the past 10 years, not just the past 100 years. The full past 10 centuries of recorded history. One part of the study zoomed in on a specific stretch of ground known as Cajon Pass, a narrow corridor where the San Andreas and San Jacinto fault systems run unusually close together. Researchers described this location as a kind of gate. If a future earthquake starts on one of these faults and reaches this narrow gate, it could potentially jump across and keep rupturing along the second fault system entirely, turning what might have started as one large earthquake into something dramatically bigger and far more destructive than either fault could ever produce completely on its own. This idea genuinely changes how scientists think about worst-case scenarios across Southern California. In the past, many researchers treated the San Andreas and San Jacinto fault systems as two separate puzzle pieces, each one capable of producing its own big, damaging earthquake independently. This newer research suggests that under just the right stress conditions, those two systems could actually link together into a single, much larger combined event. One of the researchers involved in this kind of stress modeling, a professor who leads a major earthquake research center in California, pointed out something worth sitting with for a moment. Southern California has not experienced a truly major damaging earthquake inside a big city since the Northridge earthquake struck back in 1994. Based on his own assessment, releasing the level of stress this new study identified would likely require an earthquake of magnitude 7 or larger somewhere along that system. Just to give you a real sense of scale here, researchers estimate an earthquake that size striking Southern California today could affect close to 24 million people spread across the greater Los Angeles metropolitan area and the Inland Empire. It helps to understand just how much stronger a magnitude 7 earthquake really is compared to the small 4.2 that woke everyone up near Frazier Park. Each whole number on the earthquake scale represents roughly 32 times more energy released than the number below it. That means a magnitude 5 releases about 32 times more energy than a magnitude 4. A magnitude 6 releases about 32 times more than that. By the time you reach magnitude 7, you're talking about tens of thousands of times more energy than the small quake that made headlines on July 12th. It is the difference between a kid tossing a pebble into a pond and an entire cliffside collapsing into the ocean. The Northridge earthquake, back in 1994, even though it was considerably smaller than what these researchers are now describing, still caused billions of dollars in damage and remains one of the costliest natural disasters in the entire history of the United States. Now try to picture something even bigger, hitting a region that has millions more residents and vastly more buildings, roads, and infrastructure than it did back in 1994. So here is exactly how all of this connects together. A small earthquake struck near Frazier Park on a lesser-known fault, sitting caught between two much bigger giants. One of those giants, the Garlock Fault, has been silently building pressure for up to 1,000 years and got an extra push from the 2019 Ridgecrest earthquakes. The other giant, the Southern San Andreas Fault System, is now showing stress levels higher than anything ever recorded in the past 1,000 years. None of this means a huge damaging earthquake is happening tomorrow or even this year, but it paints a picture of an entire region that has been quietly loading up pressure for an extremely long time with fewer and fewer places left for all of that pressure to escape quietly and safely. And as it turns out, California was not the only place on Earth feeling a little restless around this same stretch of time. The pattern actually gets even stranger once you zoom all the way out and look at what else was happening around the planet in the weeks leading up to this quake. A restless planet. Here's something that will genuinely make your head spin a little bit. On the exact same day, back in June, that a magnitude 5.6 earthquake struck Northern California near a small town called Redwood Valley on the completely opposite side of the planet. The country of Venezuela was hit by one of the most devastating earthquake disasters that region has seen in generations. Two massive earthquakes struck within seconds of each other, and the death toll from that single event climbed into the thousands in the weeks that followed, with tens of thousands of people left missing in the rubble. Just a couple of weeks before that same event, a magnitude 6.1 earthquake struck near the coast of Cuba, felt away as Florida. Around that same general stretch of time, a separate magnitude 6 earthquake also hit down in Baja California, Mexico. None of these individual events prove any kind of direct guaranteed connection to what happened later at Frazier Park. Scientists are usually very careful about linking earthquakes that occur thousands of miles apart from one another, since some overlap in timing is always bound to happen naturally purely by chance, given how many earthquakes are constantly happening somewhere on the planet at any given moment. But taken all together as a group, it does paint a picture of a planet that has had an unusually busy stretch of weeks, releasing built-up pressure across several different regions all around the same time. It is worth remembering that the Earth's crust is not made up of separate, unconnected pieces sitting quietly on their own. It is one giant shell of rock broken into a handful of massive plates, all constantly pushing, sliding, and grinding against each other at the same time all around the globe. Most of the time, that motion happens slowly and quietly, in ways nobody on the surface ever notices. Every once in a while, though, several plates seem to let go of built-up pressure within a short stretch of time, and it can feel like the whole planet suddenly got busy at once. Scientists are still working to understand exactly how connected these distant events really are, but moments like this stretch of June and July 2026 are exactly the kind of window researchers study closely afterward, looking for patterns that might only become obvious once enough time has passed. There's one more strange little detail worth mentioning here, even though scientists are quick to point out that it is far from scientifically proven. Just hours before the Frazier Park earthquake struck, the sun let out a solar flare strong enough to knock out radio signals on the completely opposite side of the world, affecting parts of the Middle East and India. Some researchers have explored the general idea that intense solar activity might have some kind of subtle, indirect effect on Earth's upper atmosphere, and through a long, complicated chain of physical events, possibly even some tiny influence on geological activity down here on the ground. This is a genuinely early-stage area of research, and most mainstream scientists are very careful not to draw a straight, confident line between the two kinds of events. Solar flares happen fairly often throughout any given month, and earthquakes are happening constantly somewhere around the world at basically every moment. So it is incredibly easy for the timing of the two to line up without there being any real underlying connection at all. Still, it remains an interesting little detail from an already unusual morning in California. There's one more thing worth knowing before we wrap this up, and it might be the most humbling part of the entire story. Even with all the satellites, sensors, and decades of mapping, California has scientists can still get caught off guard by faults nobody even knew existed. Back in 2014, a fault running through Napa County produced a magnitude 6 earthquake, and researchers had to scramble afterward because that fault had never even been formally documented before it ruptured. It simply was not on the map until the moment it moved. That is a pretty strong reminder that earthquake risk in California is not limited to the famous, well-studied fault lines everyone already knows the names of. Smaller faults hiding in plain sight, just like the Plato Fault near Fraser Park, can matter just as much as the giants sitting next to them. So, what do we actually take away from everything we just covered? A small, mostly harmless earthquake struck a quiet mountain town in California. The fault behind it was not even the one that everyone online originally assumed it was, but the surrounding region is carrying more built-up stress than it has held in a very long time. Sitting caught right between a fault that has stayed silent for up to 1000 years and a fault system that scientists now say is under more pressure than at any point across the past 1000 years of recorded history. None of this is meant to scare you into thinking something huge is about to happen this week, or even this month. Nobody can honestly predict that with any real precision. What it should do instead is remind you that living anywhere near a fault line means being ready, not scared. Keep a basic emergency kit at home, stocked with water, some food that does not go bad quickly, a working flashlight, and a first aid kit. It is worth having enough supplies to last your family at least 3 days, since roads and stores can be hard to reach right after a big quake. Know exactly which spot in your house is the safest place to take cover during shaking, usually under a sturdy table or against an inside wall away from windows and tall furniture that could tip over. Have a simple plan for how your family will reach each other if the phone lines get jammed right after a big event, including picking one out of town relative or friend everyone can call to check in. It is also worth downloading an earthquake early warning app on your phone, since even a few seconds of notice can be the difference between standing in the open and already being safely under cover. None of that takes much time or effort to set up, but it can make a real difference on the day it actually matters. If you found this whole breakdown interesting, go ahead and hit like and subscribe so you catch the next update the moment new research comes out on any of this. And here is a question for you before you go. If you live in California or really anywhere near a fault line, do you actually have an emergency kit ready to go right now? Let me know down in the comments.